Welcome, friends of the Greasy Shop Rag. Today we're going to take a look at a Stihl 066 chainsaw. The customer complaint is that he doesn't think fuel is moving into the cylinder. The saw won't start. He's looked at it a little bit and he can't figure out why this is happening. So we're going to start this repair like we would any other one. We're going to look in the fuel tank. That fuel filter doesn't look the greatest, and we have learned in the past that bad fuel filters could prevent a saw from starting and running properly. I don't think that's the case here. We're pressure testing the fuel line. That fuel line seems to be holding pressure. So for now, we're just going to push that filter back on and drop it in the tank. Probably should take a look inside that tank and make sure there's no water in the bottom of it. And it looks good. I don't see anything wrong inside of there. Fuel smells okay. I don't think that the fuel quality is the problem here. Let's take a look at the air filter. That looks fine. I mean, that wouldn't stop fuel from moving into the cylinder anyway. But we could take a look inside the cylinder and see if we have any scoring going on or anything like that. If we had a problem with, I was just looking at this spark plug. It doesn't look terrible and it's dry. Of course, we weren't pulling on the cord recently. I was going to say, if we're not creating a pulse in the crankcase, then we wouldn't be running the fuel pump. And, you know, if it was totally set rings in the piston and we're not creating any change of pressure in the crankcase, you know, that could contribute to a fuel pump not running properly. Let's check the compression on here. Anything over 100 and I'm satisfied that this thing should start. The decompression button is pushed in. I got to take a scrunch and kind of pry it back out. So what do we have? I can tell it's over 100. What am I at? I don't know. 130, 120? I'll take a closer look at that later. All right. Well, I guess we could check for spark. I mean, obviously it's not going to start if we don't have spark. Although he says he's already been past this point, and he does have spark. So I don't like these Stihl switches, but I guess we're in the on position. We must be. We had spark. So we'll put a fresh plug in here. You know, we got a clean cylinder. We'll get the saw running one way or the other. And we'll torque that plug down to spec. There we go. Okay, well, let's take a look at the muffler. If the spark arrestor screen is plugged up, carboned over, completely blocked, anything like that, then air won't be able to move through the engine. And if air can't move through the engine, then air can't pull fuel along with it through the engine. And that would result in a dry spark plug. But spark arrestor screen looked good. So now that we've looked at all these things, let's see if it starts. So that was 12 pulls. Nothing. This doesn't have a primer bulb on it, and it's been my experience that it usually takes 10 pulls to prime a dry carburetor. So we gave it 12. Still nothing. And in fact, the spark plug is bone dry. Well, for me, that means we got to pull the carburetor and look inside. Now, reasons why the carb could be dry would be, if we had a stiff metering diaphragm and the needle could not open in the carburetor and let fuel in, then you'd have a dry or a dry cylinder. If your impulse hose isn't working for whatever reason, could be disconnected or no pulse from the crankcase or blocked, bad diaphragm in the fuel pump, all those things could contribute to the fuel pump not working and pulling fuel out of the tank into the carburetor. So we're going to have to pull the carb and figure out which one of those things is going on, if any. The first thing I'm going to do is I'm going to pop the throttle linkage off the side of the carburetor. I'm kind of holding the throttle open with the screwdriver and then using the pliers to lift the linkage out of the slot in there. Now I'm taking the fuel line that comes from the tank and the filter and goes to the carburetor. I'm removing that. Then I'm going to take a Gulf tee and plug off that line once I get it off of there. I'm going to release the pressure in the tank by loosening the cap. Pull the line off, plug it. And, Gulf tees work, but they're not the greatest. They don't always seal. Sometimes they got a clear coat on them or something and they pop out of there. Like if you use a Gulf tee in a impulse port and pressure test the crankcase, it can easily blow that tee out of there. Looking into the intake, the boot looked fine. The piston skirt looked fine. Let's open up this carburetor and see what we got going on in here. Four little screws hold down the metering diaphragm cover. And underneath it is the metering diaphragm itself. And this is about the most unstiff metering diaphragm I've ever seen. This thing's very pliable. The metering lever seems to work. The needle's not stuck down. We're just going to check the metering lever height here for this carburetor. And that it's set right. Looks good. There was fuel. The diaphragm was wet. Okay, so there was a little bit of fuel hanging around there. But the saw never actually popped. Let's take a look at the fuel pump. Maybe the microscreen is totally plugged up and that's preventing fuel from flowing. Or maybe not. It looks fine. So, now what? Well, the next thing to do is going to be to pressure test this thing. The contents of the tank look good. The fuel line looked good. The carburetor looked good. The inside of the cylinder looked good. We had spark. We put a new spark plug in it. Let's pop the hood off of here and get a closer look at the cylinder and gain a little access to more components so we can pressure test it. 3 screws hold this cover on. And I think we can sneak it off without removing the spark plug. Yeah. Alright. So what are we going to do next? We're going to block off the intake. This is a special adapter from Stihl. Allows us to connect our pressure pump right to this adapter. Now, this may not be the exact adapter for this saw because I'm having to plug that impulse line. You probably make one that's a one-piece unit that would plug that line while you bolt it down. On this side we have the muffler and we're going to have to put a block off plate in place of the muffler. We want to seal the crankcase so when we put pressure in it, we can look for leaks. So here's our Mightyvac MV8500 pump. And you can see that we cannot build pressure. There's a big leak somewhere. We're going to spray around our intake adapter. We're going to spray around the intake boot. I don't see any bubbles. Maybe the plate we put on the exhaust is leaking. No, I don't see any bubbles there either. Is it the decomp? No. Well, I just noticed something. It's a very obvious problem that was kind of hidden. We'll take a closer look at this and I'll show you what we found. So the cylinder requires 4 bolts to hold it down into place. At least one of them is completely missing here. And in fact, 2 of them are. So now when I spray the soapy water around the base of that cylinder, I can see it leaking there. And as it turns out, those 2 rear bolts are both broke off into the case. I'll show you that here in a minute. And the 2 screws that hold the front of the cylinder down, not even tight. Now is this, has someone been in here? Did they not properly torque it down? Has it just been like this since day one? You know, I shouldn't say been like this. I should say, has it happened naturally since day one, where those 2 screws, I wanted to say come loose, but they didn't come loose, they broke. So I think there was some monkey business going on here. We had a air leak in a lean condition, but I don't think it lasted long. I think those bolts broke. And then this wouldn't run, because the piston and cylinder look okay. But you can see that bolt, which is supposed to have a head on it, is just completely broken. So I had to order a new base gasket and 4 new bolts. And once you know it, 3 of those bolts were back ordered. So it was a couple weeks since I last worked on this. Which probably doesn't matter because I don't work on 066s a whole lot anyway. So it's not like I'm going to forget how to do something. I kind of working my way through it anyway, you know. Which doesn't matter because these things are all the same. I mean, they all work on the same principles. There's nothing crazy different about them unless you're talking about Auto-Tune or M-Tronic. So what we're going to do is, we got our new base gasket on here. We're going to use this red ring compressor. There's 2 rings on this piston, and we got to get the ends of the gaps of the ring lined up with the locating pin on the piston. Once we do that, we can put a little bit of a holder underneath the piston and run it down so it's setting on top of that holder. And then we squeeze the red ring compressor with our hand and push the cylinder over the top. So the cylinder is over the rings. Now we have to get the intake boot lined up, and we'll push it through the orange firewall, we'll call it. So the 066s and I guess they'd be MS660, they don't all use the same size screw for the cylinder. Some use an M5 screw, and that one would get torqued down to maybe 11 Newton meters, somewhere in that range, 11 to 12. And the 6 millimeters that this 066 uses get torqued down to, I believe, 14.9 Newton meters. And I do it in steps. You know, if it's 14.9, I might go to 6 and then 12 and then 14.9. And I don't think I actually have my torque wrench set at 14.9. I think I got it set at 14. So now we're going to pressure test this crankcase, and it's going to hold pressure. So the only leak that we had was that cylinder base gasket because of the broken bolts. And then we'll do the same thing with the vacuum. We'll pull the vacuum on here and make sure the crank seals are good. And they will be. It'll hold the vacuum. And this is an important step because to keep moving further from this point without testing this would be foolish, really. Alright, so we'll kind of speed through here a little bit. We'll have to take our block off plate off the exhaust and then install the muffler. And then we'll get a bag full of goodies. I mean, I told you I waited a couple weeks for them bolts. So everything got put on a shelf. We got a carburetor and our air filter. Some plastic bits and some rubber bits. Some hardware. We got our broken studs. We're not going to need those. We got our carburetor. And a dust boot. So we can pop that golf tee out of the fuel line. First we're going to crack the fuel tank so there's no pressure there. We'll slide the carburetor over the studs. Remove the golf tee and push the fuel line onto the carburetor. And looking at my greasy shop rag, it looks like it's getting wet. There's a stain that's forming underneath it, big wet spot. And that's because I cracked the fuel cap and forgot to retighten it. So we went from greasy shop rag to gassy shop rag. So on the other side we installed the carburetor linkage, the throttle linkage, and you'll notice me spinning a nut off the carburetor. That's because I kind of temporarily tightened that carb down to install the linkage. It was moving around on me, and there's probably a better way to do it. You take that black handle off of there and you can manipulate the linkage a little bit easier. I like taking shortcuts. We installed the rubber dust boot. Then we're going to put our air filter adapter in place. And the nuts that hold that down are the same nuts that are holding the carburetor down tight. There, we got her snugged down nice. We're going to put our cylinder cover back on. We can kind of sneak this into place. So here I'm going to use a magnet to drop the screw down into place. Then I'm using a scrunch to hold the head of that screw and remove the magnet. Then I move the scrunch out of the way and then I can access the screw and tighten it down. The reason this saw wouldn't move fuel into the cylinder was because with a loose base gasket or an air leak at the base gasket, we weren't creating a pulse in the crankcase. Any pulse that would have traveled through the impulse hole was lost at the air leak at the base gasket. So we weren't running the fuel pump. We weren't able to pull fuel from the tank into the carburetor, and we weren't able to draw air through the carburetor because we were drawing air past the leak at the base gasket. So the leaky base gasket kind of had a combo effect of not allowing the pump to work and not allowing air to be drawn through the carburetor. So now that we've got that all put together, let's see if this thing fires up. And if it does, then that's all I'm going to have for you on the Stihl 066. It had some broken cylinder bolts. Thanks for watching. Later.